Okay, so today we're going to be talking about Boyle's Law, Avogadro's Law, Charles' Law, and a little bit about the ideal gas law. So let's go ahead and begin with this. So for Boyle's Law, there is essentially an inverse relationship between pressure and volume. So pressure is going to be known as P. So it's pressure, and V is going to be known as V. Actually, let me just write down Boyle's Law somewhere here. Boyle's Law. Okay, so as pressure increases, volume decreases. Similarly, as pressure decreases, volume increases. So, let's say we had a container, and this was little, kind of like a syringe. Let's make it, this is the needle. So, let's say we had a bunch of, particles in the syringe. This was my little stopper right there. So, as we pushed this, the pressure would increase, but the volume would decrease. Similarly, when we push this back, the volume would increase, but the pressure would decrease. So there's your little explanation there. Okay, then we got Avogadro's Law. Oh, excuse me, totally forgot to write about the relationship. So we got P1 V1 equals P2 V2, and then we got pressure volume equals the constant K. So those are your two equations. Either one will work. Just depends on what you're doing at the specific time. Avogadro's Law. Avogadro's Law. It's the relationship between the gas N, gas is always written in N, and volume V. So as the amount of gas increases, so gas N, as the amount of gas increases, volume V increases. So this is a direct relationship. So increases. I'll just do a different color. Decreases. So we've got that. And then so the constants and this are the temperature and the pressure, because we don't really worry about that when we're talking about Avogadro's Law. It's just the gas and the volume that we need to take into consideration. So therefore, the equation would be N1 over V1 equals N2 over V2. That's the equation. And make sure you know this, that Avogadro's Law, gas has to be in moles. So gas has to be in moles in Avogadro's Law. And then also one thing to make sure is that volume has to be in the same units. For Avogadro's Law, volume has to be in same units. So let's say if I had 20 liters of nitrogen, so I can't have 20 pints of nitrogen. So they had to be in the same units. So liters, pints, gallons, whatever. So next we've got Charles' Law. So with this, a big key thing is the higher the temperature, the higher the kinetic energy. So that's just a quick concept that you probably did before you learned all these laws, or learning all these laws. So this is another direct relationship between volume and temperature. So as volume goes up, temperature goes up. As volume goes down, temperature goes down. So remember this, that you have to always use Kelvin for any temperature that you're using with the gas laws. So, especially with the Charles Law, it's something to remember. So, Kelvin, so if you're dealing with Celsius, Kelvin is found by the number of degrees, Celsius plus 273 equals your big K Kelvin. So we got that, and then the relationship can be stated as V1 over T1 equals V2 over T2. So that's your basic relationship. So finally we've got our ideal gas law. Zoom past these pretty quickly. Ideal gas law. For this, I'm basically just going to state that P, pressure, volume, equals the constant N, gas N times constant R, and then times temperature. So right here, this right here is the constant, and you will know this ahead of time, so like your teacher would probably give you this. Okay, well that's it for this lesson. I hope you enjoyed it. I hope it was helpful. Thanks for tuning in.